Hey everyone, and welcome to The Explainer. So let's kick things off by taking a look at this quote. It says, the proposal reframes AI scaling from buy more GPUs to optimize state flow across heterogeneous compute layers. We constantly hear that the AI industry has this massive scaling problem, that if we want smarter models, we literally just need to back up a truck and buy more and more GPUs. But what if that whole approach is just entirely backwards? What if the crisis we're actually facing isn't a lack of hardware at all, but a massive architectural bottleneck? Today, we're unpacking a really fascinating paper called Beyond the Monolithic Transformer Tri-Tiered Heterogeneous AI Architecture. We're going to dive right into the physical walls our current AI systems are hitting, and we'll unpack the radical, ground-up redesign that researchers say is absolutely required to fix them. All right, here is our roadmap for today. We'll start with the hidden AI crisis, move on to the KV cache bottleneck, explore a tri-tiered solution, look at changing scaling economics, and finish up with the future AI landscape. Okay, part one, the hidden AI crisis, or what we are calling the overburdened monolith. Let's think about how modern AI is deployed right now. The industry basically forces a single hardware substrate, the GPU, to do absolutely everything at once. We're making it act as a semantic inference engine, a persistent conversational memory store, an orchestrator, a reasoning system, and a long context retrieval mechanism. It's literally like forcing a Michelin star head chef to cook the meals, wash the dishes, mop the floor, and take reservations all at the exact same time. We are just piling every single cognitive task onto one heavily constrained piece of hardware. And because the GPU is doing way too much, providers are forced to take massive shortcuts just to keep the servers from crashing. They use aggressive quantization, which is basically squishing the model's brain down and sacrificing nuance to save space. They artificially shorten your active context windows, and they completely flatten out edge case reasoning. So to keep things running, they're sacrificing high-fidelity cognition. They effectively optimize the AI to only handle your average median interactions well. Which brings us to section 2, the KV cache bottleneck. Basically, how models get trapped in their own context. This introduces a really wild concept called contextual gravity. And this explains exactly why models suddenly get slow and, frankly, kind of dumb when a conversation drags on. When you force memory and compute to live in the exact same place, all those prior conversational states remain statistically active. It makes pivoting to a new topic incredibly sticky. The model is essentially trapped inside its own accumulated context trajectory. It literally gets weighed down by the irrelevant history of the conversation. You can actually watch this domino effect happen in real time as context windows grow. Check this out. First up, memory pressure spikes. Second, bandwidth demands shoot through the roof. Third, inference throughput just falls off a cliff. And finally, the GPUs become entirely memory-bound during generation. So the fundamental problem isn't just that we don't have enough memory. It's that our current architecture is tightly binding active attention and long-term conversational memory together in the exact same hardware. So what's the fix? Let's move to section 3, a tri-tiered solution, where we completely deconstruct the architecture. This is the absolute core of the explainer right here. We have to stop treating the AI as this all-in-one magic black box. The proposed solution is to rip the transformer apart into 3 highly specialized independent layers. Tier 1 uses standard CPU servers and DDR5 RAM to handle persistent state and orchestration. Tier 2 uses GPU clusters exclusively for stateless semantic inference. And Tier 3 brings in specialized custom chips, like ASICs and FPGAs, for deterministic symbolic logic. Let's break down why this is such a game changer. Starting with Tier 1. Now, in legacy setups, CPUs are kind of just treated as a general compute afterthought. But in this new architecture, the Tier 1 CPU layer steps up to take over the role of persistent memory. It externally maintains your full chat history, handles context management, and manages those topic pivots without triggering any of that attention gravity we just talked about. By letting the cheap, abundant CPU handle the conversation retention, the rest of the system is entirely freed from carrying that baggage internally. Now, Tier 2, this is a massive shift for GPUs. Instead of a single GPU acting as a persistent entity that owns your specific conversation, Tier 2 turns GPU clusters into a totally interchangeable, stateless compute pool. They are used strictly for intent inference and pattern extraction. Because they aren't babysitting your memory anymore, literally any available GPU can just grab the current workload, process it, and move on. Cluster efficiency absolutely skyrockets. And then there's Tier 3, which really clarifies the difference between probabilistic and deterministic execution. Look, neural networks are probabilistic. They are fantastic at generating semantic estimations, but at the end of the day, they are guessing. When we need absolute 100% mathematical correctness, we route that to the deterministic layer. Tier 3 uses specialized hardware to execute hard math, rule evaluation, and formal verification. We are finally separating semantic interpretation from hard-coded logical execution. Moving on to Section 4, Changing Scaling Economics. This is a total financial paradigm shift. Because this isn't just about making the software run better, it flips data center financing completely on its head. Look at this contrast. You are paying hundreds of dollars per gigabyte for high-bandwidth GPU memory versus just a few bucks for commodity DDR5 RAM. This highlights the absolute financial absurdity of how we do things right now. We are forcing long-term conversational memory into ultra-expensive, power-hungry GPUs instead of just using cheap commodity hardware. It's crazy. So you might be wondering, if this is so obvious, why hasn't the industry switched yet? Well, massive infrastructure lock-in. The whole ecosystem is deeply addicted to monolithic GPU scaling. We're fighting Nvidia's CUDA centralization, rigid data center procurement pipelines, deep engineering specialization, and a web of software dependencies. The institutional inertia here is huge. Building a heterogeneous architecture makes software orchestration way more important than just buying more silicon, and that is a really tough pivot for the industry to make. Finally, let's wrap up with Section 5, the future AI landscape and what post-monolithic intelligence actually looks like. If you take nothing else away from this explainer, remember these 4 new scaling principles. Number 1, externalize your memory. 2, decouple state from compute. 3, separate semantic inference from deterministic reasoning. And 4, treat GPUs strictly as transient semantic accelerators. The scaling pressure moves completely away from just buying more hardware and shifts toward cloud-native orchestration and intelligent distributed systems design. The source material frames this takeaway perfectly. It says, transformers remain essential but cease to function as self-contained cognitive entities. They become specialized semantic processors operating inside a larger distributed intelligence system. The big breakthrough here isn't getting rid of transformers. We aren't ditching them. We're just realizing that they don't have to carry the entire burden of cognition alone anymore. Which leaves us with this one big, provocative thought to chew on. Does the future of scalable AI belong not to bigger, hungrier transformers, but to smarter, decoupled infrastructure? It's a question that totally upends that just buy more GPUs mindset that is dominating the industry right now. Thank you so much for hanging out with me for this explainer. I really hope it gave you a fresh perspective on the future of AI architecture. Keep learning, and I'll catch you next time.